Hello, my name is Mohammed Al Bast. I am the leader of Personal Issue Tracker project, and today I will be showcasing our PIT, read, proposal, traceability, diagrams, and the poster and presentation documents, and a quick overview. So, starting with the proposal, these are the members that are participating in the project. Here we wrote in the abstract, introduction, some related work that some researchers we've done among choosing this subject. And here we show out the details, some deliverables, some diagrams, use case scenarios, some sequence UML diagrams. Here we showcase our timeline, what we expected to achieve in each week, and that was achieved and done the way we planned to. And that's thanks to the professor's also's homeworks. Here we showcase the environments that we've used, PostgreSQL, SQL, CSS, HTML for front end, JavaScript, all these kind of tools and technologies we've used to make up for the project. Here, this is me, Mohammed Al Bast, the project leader, and my responsibilities. Manar Mansour, tester, and it's responsibilities. Mamadou Massaman, Majid Shahani, Moazgad for developing the project. And here we write out the conclusion and what we expect this project to do. The poster, we have submitted that also in the homework 7 submission. This is the poster we've worked on, issue tracker system, full stack web application for managing tasks and bugs. Here we summarize the introduction, the abstract, methodology, implementation, features, issue workflow, discussion and conclusion, some results, some outcomes, some references, everything. And also, this is the read document we've worked on. Again, the first page includes the team members and whatnot. Here we make the requirements elicitation analysis document. This is the title of the document. Here we showcase the version, the reviewers, which are developer and tester, and also the professor, the instructor, Haluk Gümüşkaya. Some stuff we changed. Also, this is the last version of the document. I forgot to mention that. We started with 1.0, 1.1, then 1.2, the last version. This is the table of content we have, up to 8, including English abbreviation, description, architecture requirements, functional requirements, all non-functional, elicitations, introduction method, the purpose of the document, the scope of the project, all of this, the same as the template the professor has shared with us. This is the high-level requirements summary, including all the requirements. Then we divide them into functional requirements. Then we move into the type of functional, like issue discovery and dashboard we got to, administrator functions we got to, and then non-functional requirements. Also, we divide them into their own categories, some constraints, either they are technology constraints or REG constraints. Here we go to requirements analysis, why we chose what we chose, use case scenario, use case diagram, use case scenarios here, ER diagram, this is a class diagram, sequence diagram, component package and deployment models. We showcase here all the models used, deployment diagram. Also, we got this system architecture, what we've used and why we've used it, the tools and whatnot, some dashboard and login screen. this is the UI that we're gonna use. Sorry about that. Traceability, and yes, that's the read document and the conclusion in the end, what the aim of the project and whatnot, and what do we include from whatever we've done until now, and some references, of course, for all the tools and everything we've used for, and also the book that the professor shared with us, the lectures. And now we're gonna go to PIT traceability. It showcases what kind of what we were able to implement and what not when it goes to functional requirements use cases. This is what we have achieved into implementing, and API, the module, test case, function requirement UI, non-functional requirement component, and full matrix. As a summary, we go to the presentation and a quick go around the presentation. This is the project presentation for the issue tracker, the overview and the objectives, technology stack, what we've used and the tools, core features and user roles, issue workflow and security, presentation roadmap, what we're gonna go through during our presentation, problem statement and project goals, authentications workflow, database design, REST API summary, testing strategy, coverage and traceability for BDD, results, strengths, and future enhancements. This is actually a very key point in case we want to develop even more our project and work more on it in the future. And the last page, which is the poster of the project and the deliverable submitted. So that's about it. And here in the README, we showed the GitHub link. And yeah, hopefully it is enough. Thank you so much.
Hello, Doctor. I'm Manar. My main role in this project was testing and system validation. I worked on different types of testing, including unit tests, integration tests, BDD, and IBI testing using Swagger. The unit tests were used to validate the internal logic of the code, especially the service and middleware. I mainly worked on Earth service, issue service, middleware. After fixing some issues in the mocks and expectations, the main unit test passed successfully. You can see here. And I worked on integration tests, which check whether different parts of the system work together correctly. This tests perfect connection between route, service, and database. I also have I also worked on BDD files, which describe the system behavior from the user's point of view. BDD part includes feature files and step definition files. I used Swagger to manually test the main IBI endpoints of the project. I test endpoints such as register, and you can see here login. Login successful. And issues, post issues, create issue by ID, and update issues. Through Swagger, I verified that the main API function were working correctly. And thank you.
Hello everyone, my name is Mahamadou Traore. I am a developer in our team. Today I will show you our web application. It's called Personal Issue Tracker. It helps users to create and manage their issues. This is the login page. The user writes their username and password here. Both fields are required. If the user leaves them empty, the system shows a required message. When the username or password is wrong. This is the register page. A new user can create an account here. They need to write three things: their username, their password, and their full name. All fields are required. When they click register, their account is created. Let me create mine. Open mine. This is the main page of the application. After login, the user can see all the issues here. On the left side, there is a sidebar. It shows the status of issues, all, available, in progress, and finished. The user can also see their username here. There is a logout button at the bottom. Wait. We also worked on admin progress, a feature to help administrators manage user and issues more easily. On the top, there are priority tabs: all, high, medium, and low. Each user's card shows the title, description, creation date, and status. The filtering system allows users to filter issue by priority and status. We made the filtering functionality work correctly so user can quickly find the issues. The colored dot on each card shows the priority. Red means high priority, yellow means medium, green means low. There is also a plus button at the bottom to create a new issues. The issues are connected to a real database using Supabase. So the data is saved in the cloud. Let me create one. In conclusion, this is our prototype. It has login, register, filtering, and a dashboard with real data. Yeah, and thank you for watching.
My name is Majid Shahani. I was responsible for the complete backend implementation, the project setup including dependency management, repository structure, and CI/CD configurations, as well as a good bit of the front-end development through structuring and API integration. The backend follows a layered architecture split into controllers, services, and repositories. Controllers are responsible only for handling HTTP requests and responses. As such, services contain all the business logic, and repositories isolate the database access. These are database access and Here lies the business logic. This separation ensures that business rules remain independent of transport and persistent layers, making the system easier to test and extend. For example, issue state transitions are enforced through a validation layer in the service using a defined transition map, in here, preventing invalid state changes from ever reaching the database layer. That means if our issue is in the available state, it cannot suddenly jump to the finished state. This validation is done on the server in the service layer. Authentication and authorization are handled using JSON Web Tokens stored in HTTP-only cookies. This reduces the exposure to token theft via cross-site scripting attacks. Authorization is enforced through middleware that centralizes role checks. Here being my middleware. The token is given to them upon a successful login. Here. Authorization is enforced through middleware that centralizes role checks, allowing consistent protection of admin-only and user-specific routes without duplicating logic across controllers. This structure keeps security concerns isolated and reusable across the system. A key design decision was enforcing strict environment validation at startup. Here bring the validation function, which is called when the server runs. The application will fail if critical variables such as database credentials, JSON Web Token secrets, or client URLs are missing. This prevents misconfigured deployments from running in unsafe or unstable states. The system is built on PostgreSQL due to its relational strengths, particularly for modeling users and issues and their relationships, as well as its transactional consistency. That is especially important when multiple users are trying to update an issue state at the same time. Connection pooling is also used to maintain performance under concurrent requests. This is our database, Postgres database, which is deployed on Render currently. For the database design, I used UUID-based public identifiers instead of exposing internal numeric IDs. This improves security and keeps the API more abstracted from the database structure. For example, if I exposed the internal IDs, an attacker would then, for example, see the ID 581 and then be able to guess that an ID 582 exists and try to corrupt the data or access data from another user. These are the issues. They each have their own public ID, and they are these are the users. These are the issues, and the issues are also linked to users via their public ID, not their internal IDs. On the front end, I structured the application into separate rendering, state management, API, and UI layers. I implemented the dynamic issue filtering, sorting by priority and status, writing reusable model systems, and responsive issue cards. Here's our state that is separate from the rest of the front end. Rendering is again updating the data inside the web page based on the state, and our UI structure here just defines the overall structure without making any guesses on the data. And here they all are coordinated together. I also configured the development tooling for this project, including Webpack, ESLint, Prettier, Jest, and set up CI workflows with GitHub Actions to automate validation and maintain code consistency. For example, here we can do, which would format the code to a consistent style between every developer in the team. These are checked on the GitHub Actions as well.